My job. So the next speaker will be Erin Buehler from the University of Maryland.
Hi. Sorry for all of our exciting technical difficulties. So as was mentioned, my name is Erin Buehler. I am a PhD student at the University of Maryland, Baltimore County. I'm actually pretty close to being a PhD candidate, so keep your fingers crossed for me in the coming month here. I wanted to mention this is my first time at W4A, and I'm very excited to be here. After dinosaurs and science fiction films, probably my two favorite topics to discuss are education and accessibility, so I'm pretty delighted to be able to attend. And I am presenting this paper, Accessibility Barriers to Online Education for Young Adults with Intellectual Disabilities. We did not win longest title, but we tried. And I'm presenting on behalf of myself, my colleagues William Easley and Amy Poole, who are also grad students at UMBC in the Human-Centered Computing Program, and of course my advisor, Dr. Amy Hurst, and we're all part of the UMBC Interactive Systems Research Center. So, when to pay attention to my talk, you're welcome to nod off for the first 7 to 10 minutes, and then I'll actually discuss my findings, so check your email, whatever you want to do. I'm going to talk a little bit about intellectual disability, the motivation, the methods, the context of our study, and then dive into the nitty-gritty, the findings, and my delightful recommendations. So, I noticed a lot of folks at this conference maybe are more versed in perhaps visual impairments, not necessarily cognitive impairments or intellectual disabilities, so I wanted to take just a minute to talk about what intellectual disability is and what kinds of support students with intellectual disability actually need. So intellectual disability is a type of developmental disability, and as the name suggests, it is a disability that develops during childhood rather than onset later in life. And within intellectual disability, underneath this higher umbrella of developmental disability, there's actually a wide array of diagnoses that qualifies intellectual disability. Probably the most familiar is Down syndrome, but you can also have persons with fetal alcohol syndrome, Fragile X syndrome, and a few other things. But the two factors that are important to keep in mind when looking at support for these students are the impacts that intellectual disability has on intellectual functioning and adaptive behavior. Take a drink from my sippy cup here. Okay, so intellectual functioning is essentially reasoning and learning skills, things like scheduling, planning, strategizing. And then adaptive behavior has to do with social and practical skills, understanding etiquette, understanding exchanges in everyday life, things of that nature. So are we all square on intellectual disability? I got a couple nods, I'll take that. I'm also lucky to be presenting later in the conference because I feel like the motivation is taken care of for me. Like the past presenters, our wonderful keynote, have all said, education is becoming technologically driven. It's really important for persons with disabilities to have access to education, to have accessible technologies in the context of education. And then we have this messy beast that is the internet, where some people follow the rules and some people don't, and we have so much information. How do we filter it? So I'm really interested in how students with intellectual disability get access to education and education through technology tools. I also think it's important to support diverse learners because I'm personally afraid of this dystopian future where we standardize learning and then exclude a bunch of people early on. So, the brave new world of education, watch out. Nobody laughed, it's okay. I also care a lot about employment for persons with disabilities, and if you want to have a really long, irate conversation with me later over some beer, I'll talk about the difference between gainful employment and meaningful employment in terms of self-determination. So my methods. I take a moment, apologize to the people who reviewed my paper, who were like, what are you doing? Why are you appropriating methodologies from anthropology? What is that? But they still let me come. Thanks. So if you are not big on anthropology or you don't know about the origin of Greek words, an emic ethnography, the word emic just implies from within. So myself, my colleague William, Amy Poole, we all work really closely with students with intellectual disabilities at my school. We work as teachers, we work as assistants, and we have a lot of one-on-one activity with these folks. So we would be lying to ourselves if we said we are anything but within this culture. And science. We just want to be upfront about it and say it's emic and it's more of an ethnography than a qualitative study. We do usability testing. We just hung out and we thought. And they're letting me present that as science. And some of the methods, just participant observation, journaling by the students, looking at artifacts, and collecting a bunch of data over the course of a couple of semesters. The context for the study is post-secondary education, so not elementary school, not middle school, not high school, but post-high school. In the United States and Canada, there are at least 240 post-secondary programs for young adults with intellectual disabilities, and those programs can be vocational, they can be certificate programs, they can be integrated at a college campus, they can be segregated at a college campus, they can be a lot of things. But primarily, the goal is independence and employability. I am lucky enough to work at a school that has such a program, so I have access to students with intellectual disabilities all the time. And in the paper, we talk through two specific contexts. The first one is an inclusive 3D printing classroom, and the second one are student internships with students with intellectual disabilities. More water. So, in the inclusive classroom, I have half students with intellectual disabilities and half neurotypical undergraduates from various degree programs. The students work together in a workshop-type space, of which I have a picture up on my slide right now. Students are gathered around a big work table with like markers and crayons and paper and laptops, and they're working through design ideas for their 3D printed objects. And the premise of the class is that it functions as like an entrepreneurship minor, so the students create an outward-facing print shop for the campus where people can come and ask for 3D modeling and 3D printing services. And within the classroom, the students work in pairs, one student with intellectual disability and one student without. And the idea is that throughout the semester, as they're learning 3D modeling, as they're learning about entrepreneurship, they gain expertise in all these different areas, work together, teach each other. Lots of motivation for this that I can explain some other time. Education folks, you know what I'm talking about. So this picture that I have up right now is just a couple of groups of students huddled around a computer screen. They work on Macs. And what you can't see is the tears while they try to figure out why their 3D prints aren't printing. And then that secondary setting, one-on-one job coaching for interns. Our research lab hires an intern every semester who works on everything from 3D printing to digitizing documents for our research efforts, all kinds of stuff, very hands-on, very interactive. And those students usually have a job coach who works on them in a 1-to-1 ratio every day. In the beginning, they help with training, and then as the student transitions to being more independent, they become more supervisory, reminders, prompts, that type of thing. And there's a picture of two students working up on the screen right now, again, just sort of at the computer with the student with intellectual disability driving the mouse. Okay, so we had a time deciding how to present the findings from this because it sounds a little loosey-goosey. Like we did observations, we have the classroom, we have the student interns. We spent weeks whiteboarding this and thinking, how do we present this? What's the right framework? And what we landed on was talking about this idea of meta skills. So a meta skill is a combination of fundamental skills like memory and recall, typing, vocabulary, combined with the tasks necessary to complete some kind of an assignment or some kind of goal in an education setting. We came up with about 4 that we wanted to discuss that were kind of problematic. I'm going to step through them, and then I'm going to talk about what worked well for us in mitigating these issues and what we think the next steps are. The first of the 4 we called information retrieval. If you can imagine in a classroom, you have assignments where you have to go out into the scary world of the internet and find information. You need to know where to look for information, how to locate it, how to validate it, and then return it back in the form of an assignment or a write-up or a presentation. And our students with intellectual disability struggled with this sometimes. Lots of different factors between their own abilities and the interface and the nature of the internet impacted this interaction. One thing that we did in the classroom each week was the students had to find an article relevant to 3D printing and then digest it, write a summary, and spit it back out to us. And the students had a rough time picking the right keywords, using filters in search engines, and then also differentiating between like advertisements and click here to read more, and oh, you were interested in 3D printing, wouldn't you also like to know 15 tips for weight loss strategies? Yeah, the internet. Navigation, information, and architecture. This had more to do with the structure of the web page and being able to understand hierarchical menus, being able to navigate, understanding icons. Had some difficulty with students with intellectual disability in terms of really abstract icons and then more concrete ones. For anyone who's seen the Finder icon for Mac, it's the home base for getting all your files. It's a smiley face. And I'm like, I'm really happy about files. Files don't look like smiley faces, you guys. What is that? So students struggled here. And of course, in the classroom, lots of different places where this might come up, in a university portal, on an online website full of resources, all that jazz. Okay, more water and then file management. File management is important in digital education. You need to be able to get documents, access things for course materials, submit assignments. You might submit assignments via email. You might submit them to a portal like Blackboard or to some kind of other delivery system. You might have to maintain a blog. So being able to understand files, file extensions, where they are, where they get saved to, where you're keeping them, also important. We had two kind of high-level problems with this for our students with ID, both the interns and in the classroom. Understanding where files that are downloaded locally end up, which, to be honest, confuses me a lot of the time. Like, why isn't it in downloads? Why did it go to desktop? Why is it in this folder labeled funfetti? Nobody knows. So, identifying where things are downloaded locally, and then also abstract concepts like permissions and sharing. So in the classroom, when the students were working with their partners, they had a lot of shared documentation, shared project files, and we uploaded those to Google Drive. And for the students with intellectual disability, it was hard to conceptualize that when they access that shared folder, they're making changes to content that their partner also has access to. So we also talked a little bit in the paper about password management. Here's how I feel. Passwords are hard. We get it. There's a whole field of science for that. If you have online education, odds are you have some kind of an account-driven service. So that means more login credentials, more passwords, access issues, logouts, redundant logins after trying to reset passwords. It was a super mess. And this can be a super mess for anybody. It was just a little bit more frustrating for our students because they struggle sometimes with memory and recall. And also interfaces across different services that require a login were sometimes different. And it was confusing, a little disorienting. If a login interface changed, sometimes students would get locked out, typing in caps versus not caps, some stuff that was covered in yesterday's paper about intellectual disability. So, what's good? My favorite solution, even though I'm a computer scientist, is the solution where you don't actually need to make a new technology to solve the problem. In some cases, the problems that we identified were actually things that you could solve through education and training for the students with disabilities, but also for the kindly folks who make these interfaces and who design web portals and platforms. So issues with file naming, for example, the intellectually disabled students sometimes didn't know that they should give a file a name that was conducive to finding it later. And so they would just name it whatever, or they would download it, and then we would struggle to find it later on when they needed that file. Nobody had explained that it was a good idea to give stuff a name for future action. It's one of those scheduling and planning tasks that these students need more support for, and just nobody told them that's a good idea. Easy fix, doesn't cost anything. Costs a little bit of time. Let's not talk about how much time is worth. Other things, there are some existing considerations that are out there that would actually work really well to mitigate some of these problems. So just customized dictionaries to catch typing and vocabulary errors or to help address issues of literacy levels. Within intellectual disability, you have a really wide range of ability. You have really independent folks who don't need a lot of support. You have some folks who are very dependent and need a lot of support. And in between, there's so much room for customization of existing stuff that we already do to catch, like, every time I type the word entrepreneurship into Google, I spell it wrong. Google helps me out. Entrepreneurship has so many E's and U's in it. Okay, so we talk a lot more about that in the paper. I've got 20 minutes. I love to talk forever, but other people want to go, and we started late, so. Ideas that we think would be really valuable for ourselves and other researchers to look into that might help address a lot of these obstacles. improving visibility. So a lot of the issues that we had were related to, this navigation structure, things that are hidden or obscured in favor of looking more aesthetically pleasing. And if we could use augmentation or adaptive interfaces to kind of highlight things in a context-aware nature, that would probably help out some of these students a great deal. Another thing we thought was interesting was maybe exploring affective computing. So for our students, there's a little bit higher of a chance that you'll experience some real upset, some emotional frustration. The second or third time that you try to log into your account and you get locked out, it's rough, and it derails class and it wastes time. So when tasks are not getting completed, when they sense that the students are getting frustrated, even just alerting a teacher or a peer to come over and say, hey, what's up, do you need some help, would be fantastic. And sometimes the teacher doesn't have the resources to be watching everybody who's trying to log in, to get stuff going, that type of thing. And a little bit more water. Okay. We're super strong advocates of including persons with disabilities in designing their own solutions. And so something that I really wanted to reiterate that we've actually already heard a little bit, like in our keynote talk, is involving these students with intellectual disabilities in research and encouraging them to help with development, to become developers. These students have so many opinions on what can help them, what kind of needs they have, what their preferences are, and I feel like there's a little bit of an intimidation factor if you're not used to working with persons with intellectual disability or with cognitive impairments. Ask them, bring them into the loop. They have so much to say. And they're fantastic designers. I'm now in my second semester teaching this 3D design course, and they're great. So it's just something that folks know is out there, but I'm saying extra. Do that thing. Your champs, it's the summary slide. Pound back, you didn't fall asleep. I see you making eye contact with me. You listened the whole time. Thank you. So the summary slide, what I talked through, I presented this appropriated anthropological concept of an emic ethnography that I probably did really poorly. If you know a lot about anthropology, please don't wait to slap me until afterward. I talked through the different types of information that we kind of pulled from, how we decided to present it, those 4 meta skills that were kind of issues, and then talked through, some stuff that already exists is a good solution, offering scaffolding, using tools that we already have and reappropriating them, and then there's a few advanced solutions that might really help. This is the point where I thank all of the miraculous funding that gets me through my graduate school life, the NSF for the research, the Alexander Brown Center for Entrepreneurship at UMBC for funding my course that I designed, and then of course Canvas and Intuit for funding my student travel grant to come here. And I'll listen politely to questions and then probably not answer them well.
We probably have time for one question, and we're way behind, sorry.
That wasn't my fault.
Well, if there are no questions, I have one, just a quick one. You sort of rolled up to it. Meaningful employment, maybe just a quick, very summary what you...
Okay, so I think that there's a perception or a goal that procedural work is the end-all for a person with an intellectual disability. Because they can complete steps that are given to them in a procedural format, complete this and then follow this next step and follow this next step, there's this perception that that's the ceiling for what these individuals can do. And it's absolutely not the case, and it's really restrictive for their ability to be creative and to contribute. And so I feel like there's a big difference between, oh, well, we can make a system that gives you the ability to do a vocational build, which if that's what you want to do, like if you really like vocational skills or building, fantastic. But for the students who are creative and who are really interested in becoming designers, there should be more options for them. So I have a lot of feelings about that.
Thank you, Erin. That's all we got. Maybe you can see Erin afterwards if you have questions.
I'll come find you though.
Next up is Rello from Carnegie Mellon University. She's been kind enough to join her 2 presentations at once, so if you can hold your questions to the second presentation from her, save a bit of time that way.
Thank you, Peter.
Great.
Okay. So yes, 2 presentations in one. So first, I'm going to start with first one, with an online game designed for people with dyslexia. This is joint work with Sergi Subirats from Universitat Pompeu, Fabra, and Bigham from Carnegie University. He's not here. Okay, I think he had to run from his slide. Yeah, very important. Okay, so dyslexia. You have heard already some things about dyslexia, so I will go very fast. Dyslexia is frequent. It's about 10% of the population. Depending on the language, you have different manifestations, but it's around 10% of the population. It's universal, so it has a biological basis in the brains of people with dyslexia, and it causes school failure. Right now in Spain, and this is I'm citing our Ministry of Education, 40% of the school failure is due to dyslexia. So, what happens? Why does it cause school failure? So, what happens at school is that normally when you have to learn something, you have to read it, and when you have to prove that you know something, you have to write it. So, if dyslexia, since dyslexia affects reading and writing, you have a problem when you're at school. Okay, so that is why it causes a school failure. And normally, all the exercises and all the treatment for dyslexia are related to reading and writing. So if you have dyslexia and you have troubles reading and writing, you have plus do a lot of exercises with reading and writing, which is super, super boring. So it was like, hey, why don't we do chess? Well, maybe. We could support dyslexia, we can do something without using reading and writing, so let's try something different and see what happens. And then if we go deeper into what chess involves, we know that that also involves visual spatial abilities, it involves calculation abilities, and also executive functions, like attention, planning. And all these abilities are actually related to dyslexia. It was like, let's see what's going on. Plus, our second author, Sergi Subirats, that you can see him there in picture, he's actually a professional chess player. He's among the 55% top in the world, like chess player. So and he was my undergraduate student. I was like, hey, you're so cool in chess. Why don't you do something, for chess related to dyslexia? And then we were like, okay, so yes, okay, learning chess is fine, but let's put it in the form of a game. So games and dyslexia, believe it or not, is a hot topic at this moment. There is even research being done using action games to support dyslexia. So it has been proven, for example, this is a research being done that was done in Italy, in Padua, where they measured children playing action games, and they found out that after playing action games, before they were improving, what's going on?
So it does that.
Okay. Because they improved their attention abilities, they found out that this, like a secondary effect of improving their attention abilities, they were improving their reading abilities. So okay, so let's mix chess, computer game, and see what happens. And then we go through literature, and of course, yes, people have thought about this before, as always. So, but not with dyslexia, okay? So there is a very interesting study that was done with 92 teenagers inside it, and all these studies are longitudinal studies, like long studies, and they were measuring different spatial abilities, perceptual abilities, reasoning, creative, general intelligence, and they divided the students in two groups. One group were taking chess lessons, another group were not taking chess lessons, and at the end of the study they found out, very important, that chess improved their numerical aptitude, aptitude, and their verbal abilities. It's like, it can improve their verbal ability. Okay, but then we see other studies, and okay, there was another study done in Belgium with 20 fifth grade students, and no results were found, very unfortunately, although they also measure verbal ability. Only there were some effects on the scores that the students had. And there was another study done in Brooklyn, in the USA, and again, no differences were found between the group who were playing chess and the group who were not playing chess. So, okay, so that is more or less the state of the art of how chess and education is done. So then Sergi decided to create a game, and he made 9 lessons. He followed the World Chess Federation, let's say, ways of learning chess, which is actually the standard of how to learn chess. And he designed 9 lessons, and in each of the lessons you could learn how to and practice how to move these the different chess pieces. Yes, they are called pieces. He insisted it's pieces. It's not other words that people from outside chess world call it. Okay, so there you got it. So pawns. Are you familiar with chess? I don't have to explain this. No, pawns, bishop, rook, queens, king, knights. Yes, you are all know. Okay, I have no idea about chess. Okay, that is another thing. That is another thing why we decided to choose this, because hey, and I know so many people with dyslexia that cannot play chess, so maybe there is something there. So, okay. So the structure of each lesson is the following. So first there is a theory part, so where they explain how to move each of the pieces. Then you have exercises to learn how to learn this, and then you have like a playing part. Okay, so each lesson has like a challenge where you have like to play. Okay, and here you have some screen. I think I know why it does that. Okay, and you have some screenshots there over there. So the methodology. Okay, so we implemented this. We recruited 64 participants, 32 of them with diagnosed dyslexia, because attention deficit disorder has an impact on how people interact with the computer, especially with the mouse, and we were actually doing mouse tracking. We make sure that none of the participants had attention deficit disorder, and we also were very careful, as you can see here in the slides, that this chess knowledge were mapped among the two groups of the participants, because that could play, that could have an effect on the data that we were gathering. Okay, so we measure their performance using objective measures and subjective measures. The objective measures, okay, you remember that each lesson was divided in 3 parts: theory, exercises, and playing. So here you have the objective measures for theory. So we measure the time that they spend, the accuracy of the answers that they had. In the exercises, we also measure the time. We measure the number of squares that the mouse goes over it, because actually, this is in chess. This is a performance measure, and the number of tries for the exercises and for the answers, time that they spend to the first try, so time that they spend thinking before they move the mouse, and how many times the first answer that they gave to the questions was the correct answer. Okay, and then in the playing, when they have like to play, to exercise, how do you say this? Yes, in the playing moment, like in the last part of the lesson, we also measure number of, the time that they spend, the number of movements, time to the first movement, and the score that they have at the end. So each of the lessons have like scores. And subjective measures, very, very easy. So just using Likert scales, how do you feel? How was your performance using Likert scales? And for the people who had dyslexia at the very end of the study, so this didn't have an effect on how do they feel, we asked them, do you think that dyslexia has an impact in your performance? And we also use Likert scales for measuring this. Okay, so results. They could be more exciting. So, they could be more exciting. We hardly found significant differences. Okay, some things happened. So we found some differences always in time. So they spend more time in the theory, they spend more time doing the exercises, they spend more time playing the game, and in the only performance measure that we found differences were in the number of squares that they went through with the mouse. Like maybe they were counting, we don't know exactly what. So, and most of the participants thought that dyslexia didn't have an impact on their performance of the game. Okay, so why? Discussion. Why this happened? Okay, so when we designed the theory, the part where people started, learn how to play, chess, we use frequent words. We designed it in a way that it shouldn't have an impact on people with dyslexia, but it seems that it had. So because there was a reading component in the theory, we believe that it was what caused the differences between people with and without dyslexia, because they have to read, even if the sentences were short and in a way that we were not expecting that difference. Second, in terms of the performance, okay, what could have happened here is and you will see it in the next presentation, dyslexia is related to many cognitive skills. It's not only reading and writing. Everything is involved there. You have working memory, you have visual spatial attention, you have many cognitive skills involved. So, and people with dyslexia normally overcome dyslexia putting more strengths in these other cognitive skills. So maybe what would have happened there is that when it comes to chess, many other cognitive skills are involved there, and we could not find differences, or maybe there is not a difference at all, and that is, and then in playing, okay, the only difference that we found was in time, but in performance there were no differences. Okay, so that is, to sum up, we did not find any effects in the performance measures. Probably, because of the, of the differences that we found in timing and in number of squares, dyslexia could have some impact in chess, but it's very, we are very cautious to say this because of the results. And right now, for his undergraduate project, Sergi, in the picture, he's developing the game to be released in Android market, and we are now integrating some of the exercises that we think that might be that might cause more trouble for people with dyslexia to predict dyslexia. And this is where it comes the next presentation. Yeah. So and we are saving a lot of time. Okay. Which is the results are much more exciting, I promise you. Which is detective. It is towards detecting dyslexia across languages using an online game. So this is a joint work with Kristin Williams and Jeff Bigham from CMU, Abdullah Ali from University Mellon, Baltimore County, UMBC, and Nancy Cushen White from University of California, San Francisco. So let's go. Okay. So not to repeat myself, I'm going now to tell you other things about dyslexia. It's fascinating, no? So here you have a study that where they have done brain imaging with people with and without dyslexia, and this is a brain of people with dyslexia reading. So you can see the differences are patterned there. But okay, normally language is in the is in the right or in the left hemisphere? Okay, yes, normally language is in the left hemisphere. Okay. But in the case of dyslexia, when people with dyslexia read and write, both hemispheres, you have, okay, you know what I mean, right? So people without dyslexia, when they read only the left hemisphere, there's some parts of the left hemisphere that get activated. When people with dyslexia read, it's both hemispheres, and there's some parts that are supposed to be activated that are not activated. Okay, there we go. And now I'm going to tell you something that I think I've never shared in the research community. It's a personal story just to explain you how difficult it is to detect dyslexia. Okay, what we're doing here, we're trying to detect dyslexia, and this is to try to explain you how difficult it is to detect dyslexia. Okay, so I was 5 years old. I was in kindergarten the year before, before school, and we were all sitting in around, okay, in the class. We were all sitting in the floor, and we all had, like a little booklet, and here, and we had like I remember as if this was yesterday, okay, and we had different images and the name of the image, okay. So the teacher was going around the class and saying, okay, you read the next word, you read the next word, you read the next word. And I'm like, I'm going to read the next word. So you know how this feels, no? You need to prepare yourself, not to exclude it, no? And really to make it good in front of the class. So I was trying to prepare myself, and I just couldn't do it. Something like cross, I don't know, it's very difficult. I have a PhD on dyslexia, I still don't know how to explain this. But it was very, very difficult to So I got very, very nervous, and I was like, okay, I have, focus. So then I was like, okay, there are 4 images. Good. So I'm going to do, I think, 1, 2, 3, 4, 1. Okay. I think my word is going to be the one that Peter Thiessen is going to read. So I'm going to pay a lot of attention of what he's going to read. I'm going to remember. And then when it comes my turn, the teacher is not going to notice, hopefully. And it happened. So the girl who read the word, who now sees my Facebook friend, I look for her so many years afterwards, said pata, which means back. And I was like, okay, pata. And when it comes to my turn, I said pata. And the teacher said, yeah, very good. Okay. It was right. Hey, I got it right. So imagine, the teacher didn't notice that I had a problem. I didn't notice that I had a problem. My parents, of course, didn't notice that I have a problem because I was super careful that they never noticed. I mean, that I was like fine, like with the rest of the students. And this is how dyslexia is, People with dyslexia, we don't notice we have a problem because this is how we have access, knowledge all our lives. So we have no idea. We only assume that we are less intelligent than the rest because, of course, I kind of thought that I was stupid, because all the students could do it and I couldn't do it. But we keep on with the rest, trying not to be noticed, trying to be normal. Until, of course, school becomes more and more complicated, and then you have a problem because you cannot keep up doing this stuff all your life. So that is why dyslexia is called a hidden disability, and that is why it's so difficult to detect, okay? By everyone, by parents, by teachers, and by people with dyslexia. And then we go to how do we detect dyslexia? Well, normally it's super late, okay? We detect dyslexia when the students are failing at school. This is how you detect dyslexia. You have a student that fails at school, has normal intelligence, and maybe has dyslexia. Okay, when you are already failing, it's too late. So when we have our paper-based diagnosis, okay, there are tons of them. There is a very interesting study done at MIT, McGovern Brain Institute about neuroimaging, so they can predict risk of having dyslexia even when you have 8 months of birth. After 8 months of birth, they do brain scanning and they can predict. But of course, not many people can afford this. Maybe I don't know, Angelina Jolie. Some more people can afford this. There's some computer games to detect dyslexia. This has been done in Finnish, in English, in Dutch, but they are language dependent. And if you were last year in W4A and saw my presentation, you know that we can also predict dyslexia using eye tracking measures. But what happens? This is not scalable. These solutions are not scalable, are not affordable, are too late, they're not multilingual, and they're not fun, okay? So, do you remember W4A 2016? Yes, that was last year. Okay, that was in Florence. We were in the coffee break. That was right after my presentation of using eye tracking measures to detect dyslexia, and it was with Jeff and Abdullah. We met in the coffee break, and I was like, to help, we're going to use games to predict dyslexia. No, let's forget about eye tracking. Let's forget about anything that can be expensive. Let's do something scalable. And we were so excited about this. Like, oh my god, this is. And we took a picture of us, and yes, that is. So now we're presenting the results of the idea that came in the coffee break from last year, W4A. So, what happens here? That there's so many things that, so many behaviors that are different between people with and without dyslexia. But what our starting point after trying a lot of stuff actually was like, oh my god, we had this in front of us all this time, all these years. And that was using errors, so the input that people with dyslexia do as a source of knowledge, okay? So people with dyslexia, when they write, when they read, they make a lot of errors, and these errors are actual indicators of the difficulties that they have. So why don't we use the errors that they make, like the input that they do, to create games based on this, because probably their behaviors are going to be different to predict dyslexia. And actually, we have, we have a game made of, which is calculators, and it's like, okay, let's use all the information that we have from this game, all the performance that we have from children playing with this game since 2012. We have this game to try to get the most interesting exercises to be able to see. I mean, the exercises that are going to have like more differences between people with and without dyslexia, and see what happens. So we extracted the knowledge from this game, and this is what we did. Here you can have. No? Okay, very good. This is a video. There you go. Okay. Okay. So you're going to see it a little bit smaller, okay? So that is how detective looks. Just a second. Okay. So first there is an anonymous questionnaire where we have the independent variables.
Haz clic sobre E.
And they have 25 seconds to click as many times as possible a target letter or a target syllable or an error or other things that we found that from the exercises from before. Okay, so you have an idea. So this is composed of 32 games, and these games target specific indicators of dyslexia. So okay, so now I go again to yes, specific indicators of dyslexia. So all these indicators here are related to dyslexia. So visual memory, visual attention, working memory, reading speed, orthographic processing, phonological awareness, phonological memory, phonemic segmentation, syllabic segmentation, word recognition, non-word recognition, syntactic awareness, semantic awareness, error detection and correction, word writing and non-word writing. Okay, and working memory. Okay, so all these are related to dyslexia, and each of the exercises that we designed were focusing one or two or three, these dyslexia indicators. Okay, so here, for example, you have another example of visual attention, because we knew, from computer games that visual attention has something to do with it. So here they have to find the different letters in a record amount of time. This is another example of exercises. Here they have to find the errors in the sentences, and they need to find as many errors as possible. So, for example, smoking is prohibited on the entire aircraft. Is prohibited on. Oh yes, and it says off the entire aircraft instead of on the entire aircraft. So this kind of they need to find the errors, and then we performed the experiment. We recruited 60 participants, 30 English native speakers, 30 Spanish native speakers, 50 and 50 with diagnosed dyslexia, from 7 to 12 years old, and they had 15 minutes of play. Some of them were supervised in their school, some of them were supervised online by us, because some of them were, from families with dyslexia, and we had to make a connection via online. So per participant, we have 192 measures, but basically, it is 32 games. Okay, and per game we have 32 games, and per game we have 6 measures. And here are the measures. They are super simple. Okay, so it's number of clicks, number of hits, so exercises that are well done, number of missings, score, accuracy, and miss rate. Super simple dependent measures. So, yes, this is more exciting than the one. I'm sure. So then, if we put everything together, we find that for most of the dependent measures, we could find significant differences between groups when they play games, linguistic games, based off the errors that people with dyslexia have. Yes? Okay. So this is a new method, and it is potentially multilingual. Multilingual in terms of This can be used for languages that have alphabets, okay? For Chinese and this. But for language with alphabets, we believe that this can be multilingual. Actually, Maria Rosenberger, she's doing this for German. We have another person called Lucia Medea, she's doing it for Arabic. And finally, probably this is cheap. What is going on? This is cheap and hopefully scalable. So that we can really go to schools, and instead of waiting for the children to fail to diagnose dyslexia, this could be before this happens. I'm sorry about that. I don't know what's going on with this.
It's not you. It's
Yeah.
a technical problem.
Okay. So this is an example of how so this is the first time that we show a detective with this is an association of people, of families with dyslexia. This is in the south of Spain, and we were here doing a little informal focus group to know that the usability was fine and how to improve basically the interface of the game. This is the best. Look at this. Okay. Yeah. Okay. Yeah, that kid is the best, no? I have to tell you something about this kid. So there are three brothers, okay? Two of them with dyslexia, one without dyslexia. And then I went to one of the brothers and I said, hi, how are you doing? And then this kid came in front of his brother and told me, excuse me, the one with dyslexia is me. Okay. So, it's actually tough to say that, out loud that you have dyslexia. I was like, wow, okay. We're doing a good job because they're probably not proud, but at least, they can say it out loud. So future work that we are doing, more ongoing work that we are doing right now. So this was like the first approach for English and for Spanish. Since we had more contacts of schools in Spain and South America, we already put this, we made a large-scale study with, now it's almost 7,000, but these results are with around 4,300 students, and we use machine learning, we use recurrent neural networks, so bidirectional LSTMs, and we can predict dyslexia only for Spanish with almost 90% accuracy. We are planning to do this multilingual, and hopefully we will put this in the web, in the social media, like a little version, so everyone can share this around Facebook, and maybe in 1 year time you could see, hey, 10% of your Facebook friends have dyslexia. It's like, hey, you really? So probably one day dyslexia is not a hidden disability anymore. This can be so cool. Now we want to bring this into the schools for real. So if you really like this idea, because of course the support of all these cannot be financed by Carnegie Mellon University. Only the research was financed, but we need to put this into schools. If you like it, share this. This is a Kickstarter campaign, okay, to put this into schools, to develop this as a real tool, to pay a developer to do this, and to put this into schools. So please, don't hesitate to share this all over, because we have 14 days left, and we only have raised like 20% of the money. Yes, it sucks, yes. We are researchers, we don't know how to do it. Okay. Anyway, next time I think we will have to contract like a communication company, I don't know. But anyway, please share this all over. Seriously, because if we get this summer, a person will implement it and we will put it in the schools. And we actually have agreements with some Spanish communities to put them in the schools, so people want this in their schools. It's not, not only saying this. Okay. So that is. So thank you very much. Here are the pictures of my wonderful co-authors. And now, I think we are on time, no? Fine, okay, good. Thank you.
Okay, questions? Anyone? From the two presentations. First one was on chess-based games. Second one on detective. We have a question?
I should be like Jennison, stand next to the mic. It sounds to me when I was listening to your presentation, the key was that the games work off of a child's innate dyslexia problem. They're not able to see the E between the they don't feel like they're failing, which is the opposite of what you felt as a child, where you felt like you didn't want to fail, you wanted to fit in, so you were hiding it. Is that true that the games basically, the child just is having a fun time, and they don't know that they're missing this or that?
That is the goal. The goal is to make dyslexia detection fun. So, and that is. So, in the experiments with the schools, actually children wanted to play. I mean, maybe it's just because they wanted to play on the computer, I don't know. But they wanted to take the test. So the idea is to make dyslexia detection available, because at this moment it's not available. It's super expensive. Actually, also diagnosis, I forgot to mention this, are super expensive. And to make it fun. And this is just a screener. It's just detection. So if the teacher or the parents know that this kid has risk of having dyslexia, not dyslexic, but has risk of having any reading or writing issue, they can put solution earlier. Yes, it's not a boring test. We made a lot of effort of not making it boring. Although of course it's 15 minutes language related, so but we try not to make it boring.
Simon?
Yeah, so regarding the chess playing one,
Yes, tell me.
so if I understand it right, well, okay, I'm sorry. So as far as I'm aware, chess players' brains are different, but we don't know whether those differences are.
I don't know this. Okay.
So we don't know whether they're different based on whether they start out different or whether the chess playing makes them different as they learn it over, up to their 20s when you've got neuroplasticity at its highest. So, do you think there's what your views are on whether there might be benefit in playing chess? Would there be a benefit for dyslexia kind of the other way around?
Yes.
Yours is do lots of people playing dyslexia, playing chess with dyslexia. What about whether you just got people to play chess or understand whether people with dyslexia who play chess are feel the effects of dyslexia less, maybe?
Probably. That was the idea behind this, because we didn't find strong differences. I haven't done further experiments, so this was that's very interesting. So difficult to say, Simon. There's other studies that I haven't included them in the slides, but I read them, which they use chess for people with intellectual disabilities, not dyslexia, okay? And they found improvements. It's in the paper in the related work. I didn't know that the brain of chess players are different. This I didn't know. I should have. This is something I should have known.
Yeah, because it seems interesting that that could be something. I don't know if you've looked at adults with dyslexia who play chess, how their dyslexia is.
We found one. There is a professional adult player who didn't take the test because he was professional, who has dyslexia. He's really good, but we only found one, and this Sergi, well, he's a player, so he knows many people, and asked before the study around in his matches, competitions, and we only found one guy. So at the beginning we were going to do, the idea was to do, professional chess players with and without dyslexia. But we do
chess players who just play for fun though.
Just for fun.
Who play for fun, they might be very good, but they're not into that kind of orbit.
If we take into account not only previous literature, hypothetically it has to be beneficial. In our experiment, we didn't find differences. So because we didn't find differences a priori, it's difficult to say whether it's going to have an impact long term. We don't know because our study was not longitudinal. It was like the 9 lessons, boom, yes, that's only that. Yes. So in an ideal world, if literature review, and it will be it could be beneficial,
Great.
but we don't know.
Thanks.
Yeah.
Okay, well, thank you.
Okay. Thank you.
Okay, next up is Claudia Buzzi. Did I say that right? Great. From CNR-IIT.
Yes. Good morning. And the work is a platform to deliver cognitive games for people with intellectual disabilities. It's well known that ICT can be beneficial for students, supporting learning, but also stimulating individual potential, and can be more beneficial also for people with special needs. But accessibility issues in the tools for provide learning can be often detected. So our platform was specifically designed for people with Down syndrome, together with the clinician that train these people, but features of the platform that allow to make games customizable, make it usable also with a wider audience. Why people with Down syndrome? Because in the last years, the main age of these people has increased, and in this way it was seen that adults have a high susceptibility to develop dementia and so Alzheimer. So to contrast this trend, it's important to make brain training on specific abilities such as attention or memory, and the possibility to have a tool for make this kind of training can be beneficial. An important aspect is personalization, because this kind of people are very special, with unique characteristics. So the possibility to create a learning path specific for each individual is crucial. So we try to develop a platform with games in order to make funny activities for the users, and hoping that a computer-enhanced tools can provide a tool more effective than the classical one. For instance, helping to capture attention. The specific abilities that we are trying to train are the classical ones, so attention, memory, but also motricity. And another important the main important characteristic of the platform is that it is a rich internet application with the classical web technologies, is web-based, so can be it allows to make the student works everywhere, and the tutors of careers to check the performance result, and eventually to modify the learning path. The main accessibility aspects are related to learnability, because the learning path is performed with increasing level of difficulties, and in order to avoid errors, some implementation techniques are applied. I'm mainly focused on the visual channel, using also augmentative and alternative communication. It uses a reinforcement system, with visual reinforcement, but can be personalized. And the whole system try to make the teacher or the therapist to create the specific games usable, suitable for each individual. The platform was designed with the help of the whole stakeholders involved, so clinicians, but also people with Down syndrome. There is a specific tool in order to extract the learning trends of the training. This is the main the main page, and it is possible to access the platform in two modalities. The first is free, and it is possible to access the different types of games at the moment available. So sequence is an example of sequence, or puzzles, or that can be set for the number and so the degree of the difficulties. The classical memory games, this is an example with animals, or the families to complete. There is also a repository of video in order to make to have example of action, so to train a particular function. The second modalities is the one that it is possible after the registration. So the tutor or instructor can register itself and the child, or the student or the adult, and the additional features of the platform are the recording of data performance, and so the learning analytics tool, but also the possibility of to personalize the learning path for the student. So with personalization of content, but also level of difficulty and the creation of game. This is the user interface for the tutor, and it is possible to add new students, but also to verify the content at the moment present in the platform, or to upload content, images or videos, and to use them to create new games. For instance, this is a new puzzle games, but also a sequence, and this is the view for the student. It is possible to extract data on the performance in form of graph, but also interactive graph, but also downloading raw data. And in order to refine the software and the user interface, we performed a pilot test, first pilot test with two subjects. The result of the subject were interesting because both the users seemed to appreciate the platform and the user interface, and particularly they loved the challenge. So the fact that they have to perform something challenges for them, and the success was a sort of reinforced from itself. And so, for the the pleasant aspect of the platform, the users were interested. One of the users that was with the higher QI tried to suggest us a lot of interesting things, for instance, content to use, how to perform some action, and all the feedback were evaluated in order to improve the platform. And she was very autonomous, but the same, she had problem. Some of the main problems were related to the idea to perform in the best way the task, even if the user was informed that there is an attraction region, so it's not so necessary to perform and drag and drop task in the perfect way, because the attraction region could complete the task, but she wanted to perform the task exactly so, requiring higher time. And the problem was the connection. So the responsiveness of the internet connection was not always acceptable, and so causing a high frustration in the users. And another possible issue is that the internet connection is not always available. As a future work, we obviously want to enrich our platform, both for content but also for game collection. We started less than an hour ago, so we are always in the development phase. We are performing another pilot test for the mainly on the usability aspect, but we are trying to design a clinical evaluation. So design a user study with the clinician and psychologist in order to verify if this kind of platform can be useful and effective to train people with Down syndrome and in general cognitively impaired users. Project has been funded by the Italian government, and I finished.
Questions? Erin.
You thought you could keep me away from the microphone? Erin Buehler, UNC. Thank you very much for your talk, Claudia. I have a question/suggestion in terms of custom content. I don't know if you're familiar with the training technique of self-modeling, where you give student or you give a person with intellectual disability prompts, break up tasks into this step, sequentially this step, and the self-modeling component is where they use pictures or videos of themselves completing the tasks. And I was wondering if you were considering including that in future iterations of the game, having the people using it posing for different sort of tasks as part of the customization.
Yes, we are also performing a thesis on this platform to develop another part related to other procedure, and the step of the possible actions that can be performed by the students are also using a tablet to make a picture, videos of the activities, and enter this content in the platform in order to have a more adherent content to train itself. So I completely agree. It's one of the new try to individuate the relevant data. For instance, number of correct answer, number of attempt, number of errors, because even if the platform try to avoid errors, it records the attempt. So it depends from the game, because data recorded for each game are different, because the metrics to evaluate important things in the performance of the data are different. But at the moment we have designed for each game how data to capture, but are mainly related to the interaction and the failure and correct trials.
Okay, well, thank you. Okay. Next up is David Sloan, Sarah Orton from the Channel Group.
I know what you're thinking. The people that talk for far too long are on just before lunch. We'll be as quick as we can. So, Sarah and I are talking to you this morning as people who used to work for higher education institutions in slightly different roles, but related to accessibility. And we now work for an accessibility consultancy that is very interested in supporting educational organisations provide the most inclusive learning environment possible. And that's why we're really interested in figuring out the best possible way to support educational organisations in dealing with accessibility, which is, let's face it, a pretty fiendishly complex challenge to solve, but also one with enormous opportunities. And today we're introducing the idea of the master plan as a way to think more strategically about managing accessibility. And we also have some questions for you folks as well. So this talk is going to morph from us presenting some ideas to you to a discussion that we have either here or in lunch. So master planning is an approach that really has been present in the physical space for quite some time. A master plan is a strategic approach to decision making in a complex space, such as a city. And the slide we're showing just now is a map of Montreal. And at dinner last night, Chris LaRoche kept talking about the island that Montreal lies on. I couldn't understand that. And the map here quite clearly shows Montreal as an island in the middle of the St. Lawrence River. So maps, a map as a visual artifact or output of a master plan can help you figure out the space that you're working in. And the Montreal planning master plan is a way for the city to bring all the different stakeholders together, a way for a clear articulation of the objectives of the city as a space where people live and work and make money and have fun, to figure out what can happen in a particular area of the city in a way that the decision has been made, understanding what else is important and what else is going on. We're also seeing the master plan idea also move into the digital space. I discovered that Dublin in Ireland has a digital master plan, which is used to help define and implement a strategy for connecting the citizens of Dublin to a digital world and providing access to broadband and various other support features like that. And we saw the master plan as something that helps, that is potentially useful in helping tackle accessibility as this very complex, multi-stakeholder challenge, but with enormous opportunities for inclusion and improvement in the way that we support learning and the way that we use technology to do that. So we thought that as we are spending a lot of time working with organizations, defining and implementing a strategy, perhaps the master plan is an opportunity to move things forward. But there are lots of challenges in doing that.
And so, over the course of the last couple of days, we've seen a lot of great resources and insights that you've shared to support accessible learning. And we're here to talk a little bit about how much that work is part of an accessibility master plan. And for that, we bring our mascot, the Lorax. The Lorax is a Dr. Seuss character. And he has very valuable insights into important things having to do with trees and air. And his insights aren't valued very much, and they're not part of the master plan. And accessibility work can often feel as though it is marginal, and that it's not a part of an organizational or even a global master plan. So Dave and I work a lot with organizations that are often in education who are trying to create accessibility master plans. And one thing we see quite a lot especially within research and scholarship, is a separation between the organizations that are doing scholarship and research and the institution in which they're doing it. In a lot of cases, for example, the Research Institute, that is essentially what we call a tub on its own bottom. It brings in its own money. It has its own IT department. It has servers under desks. Does this sound like anyone's world that I'm describing here? These tubs on their own bottoms? Or are you individually a tub on your own bottom? So when we're thinking about that, there's a value to autonomy, right? And that's why that happens. But what happens is the work that you're doing here and that we're talking about today isn't part of that master plan. And so the Lorax, with all of these great insights, isn't getting integrated into some larger context. And the work that you're doing isn't, for example, helping your institution teach better MOOCs for a global audience. So what we want to talk about today with you is ways to look at master planning and to find your place within your organization or global master plan.
So we're helping you move from seeing success as having a paper accepted at W4A talking about some aspect of supporting accessible online learning to actually making a difference at your own institution or other institutions in integrating that knowledge that you have gathered and tested and had peer approved at a conference like this. And we've identified 4 key aspects, foundations of accessible online learning that could form the basis of a master plan. Very conveniently, these 4 key foundations all begin with a P, so they're easy to remember. We'll start with policy. Policy is where you identify the priorities for achieving some kind of success and the obligations that you're under, whether it's legal obligations or some other objectives relating to the success or the achievements of the educational institution that you're working for or helping. So this is about defining benchmarks and standards, looking at whether you're referencing standards like the Web Content Accessibility Guidelines or the Authoring Tool Accessibility Guidelines, and integrating them into some formal written policy that everyone understands. This is what we're trying to achieve. These are some basic requirements that we want to meet. And then there's process. Process as a formal, sort of ordered way in doing things, and particularly when it comes to the digital landscape, where that landscape is formed through people making purchasing decisions, people developing stuff, borrowing things from somewhere else, taking something that they've seen at a conference and start introducing it to their own teaching. That process can sometimes be very haphazard, and almost there may well be no process, particularly when it comes to academic freedom to construct your own digital learning experiences. If there's no defined process, then how can accessibility possibly be controlled in there? Then there are programs. the way that the master plan identifies area where central services or programs can help individuals and groups achieve their objectives and meet the obligations identified in the policy. For example, if you say that we want to use online video to support learning, to provide a richer learning experience, we also want to make sure that video is captioned, it's audio described when required. But rather than place that responsibility on every individual who's acquiring or creating that video, let's provide an in-house captioning service, or let's provide a clear way for people to request and receive captioned videos. So that aspect of the task of making things accessible is centralized. And then there's practice, the things that people do, and that's relevant to an individual's role and responsibility, so that practice is not accessibility in its widest sense, but the aspects of accessibility specific to your role, whether you're an instructor or an educational designer, or somebody working in procurement, or you work in disability support, that accessibility practice is specific to your role, and everyone works together and everyone understands what everyone else's role. So the master plan, as this holistic view of what the organisation is trying to achieve, also allows people to see where others fit into this role, and so that there's no duplication or overlap or gaps in support where everyone thinks that somebody else is doing something about it.
So to finish up, in thinking about your own work in accessible online learning and activities that we've been talking about over the course of these last days, what do you need personally and organizationally to be part of an accessibility master plan? It's a bit of a rhetorical question right now because we're out of time, but the good news is that we're working on finding answers to this question, and we'd love to have you participate. We have an accessible online learning community group through the W3C community groups. We started it up a few months ago. Dave and I are co-chairs. We're still trying to kind of get our heads around who we are and what we're going to be doing. But we've identified two major work streams, and we'd love to have you join in on them. And the first work stream is looking at a gap analysis. Sorry about all the flashing. I'm just, the screen keeps flashing for some reason. I kind of feel like unplugging it. Everybody in voting for unplug? Yeah. So we have two work streams. One is looking at the existing resources that are available through the W3C and the Web Accessibility Initiative, and looking at, okay, how do these support accessible online learning, and where are there gaps that we need to fill? And then the second work stream is looking at online learning more broadly to say, what could the W3C bring to that conversation of online learning that would support accessible best practices and get accessibility into the online learning master plan that we've all been talking about today.
And it just occurred to me when we were planning this talk how valuable an opportunity this conference is to bring in the research perspective. Now, the research and development working group that quite a few of us who regularly attend W4A were involved in, that's no longer in existence as an entity where the research community can inform the accessibility standards development process. But there is an opportunity through the online learning community group to provide a pipeline, particularly when those of us who are researching in the area of accessible online learning have an opportunity to figure out where can our research contribute to the suite of documents that the W3C provides to support accessibility, probably the informative documents rather than the normative documents. But it is an opportunity here to have a conversation, and we'd love you to join us for lunch or tea afterwards, wherever.
Yeah, we were thinking about if people want to talk more about this community group, we'll be at a table and having lunch, and we could gather together and talk about it, or maybe we'll take over the whole dining room and talk about it. Thank you very much.
Thank you.
Since we're out of time, if it's okay, would it be okay we move the questions to lunch and after?
Yeah,
Yes.
definitely.
Okay, great. So sorry about being late. Let's go eat.